Let's evaluate the limit as x approaches -4 of absolute value of x plus 4 divided by x plus 4. First we plug in -4 for x, but when we do, we end up with an indeterminate form 0 over 0. So that could mean the limit is finite or infinity or minus infinity, or it may not exist at all. So what we're going to do is find this limit first graphically. Let f of x be the function absolute value of x plus 4 divided by x plus 4. First note that the domain of this function, of course, is all x not equal to -4. So -4 is not allowed to be plugged in because we get a 0 in the denominator. Other than that, anything is permissible. So let's take a look at two cases. Case number 1, x plus 4 is positive. That means x is greater than -4, and absolute value of a positive number, so if x plus 4 is positive, absolute value of that is just a number x plus 4. Second case is x plus 4 is a negative number. That occurs when x is less than -4. And say let x plus 4 be a negative number. Pick a number, say -5. Then absolute value of x plus 4 is equal to absolute value of -5, which is 5. But we're going to write it as minus the original number -5. So now if we remove absolute value from x plus 4, since x plus 4 is negative, without absolute value we can write it as negative x plus 4. So there are two cases, one for x plus 4 positive, one for x plus 4 negative. Let's return to our function. F of x was absolute value of x plus 4 over x plus 4, but now we can write it as a piecewise function. It is x plus 4 over x plus 4. That is if x is greater than -4, and minus x plus 4 over x plus 4, and this is if x is less than -4. And this is equal to 1 for x greater than -4 and -1 for x less than -4. And we can now graph this function quite easily. So if I were to draw this set of axes, and the key number here is -4, let's extend this down a bit and say this is 1 and this is -1. The function is undefined when x is -4, so we put a hole there. For values of x greater than -4, the function looks like that. It's a horizontal line at 1, and for x less than -4, the function looks like this. Let's return to our limit. We wanted to find the limit as x approaches -4, absolute value of x plus 4 over x plus 4. We'll break it up into two limits. First, the limit as x approaches -4 from the left of absolute value of x plus 4 over x plus 4. Now, when we look at this, we approach -4 from the left from this side. The function is heading toward this point right here, and the y-coordinate of that point is -1. So the left-hand limit is -1. When we approach -4 from the right, absolute value of x plus 4 over x plus 4. So we're approaching -4 from the right from here, and the function is heading toward this point, and its y-coordinate is 1. Since the left-handed limit and the right-handed limit are different, we conclude that the limit as x approaches -4 of absolute value of x plus 4 over x plus 4, DNE does not exist. The limit is not defined. It does not exist. Now let's verify the same thing algebraically without the graph. And here's how that works. Limit x approaches minus 4, absolute value of x plus 4 over x plus 4. We'll break it up into two limits. Again, the left-handed limit, so limit x approaches minus 4 from the left, absolute value of x plus 4 over x plus 4, and then limit as x approaches minus 4 from the right, absolute value of x plus 4 over x plus 4. So let's draw the x-axis here. Here's minus 4. Approaching it from the left, we are taking values of x that are smaller than minus 4. So for example, here on the left, coming in from the left, we can take x to be minus 4.01. And let's plug that in to compute the left-handed limit. So absolute value minus 4.01 plus 4 divided by minus 4.01 plus 4. The numerator, we have absolute value of minus 0.1. In the denominator, we have minus 0.1. So this is 0.1 divided by minus 0.1, and you can see that that's minus 1. Any value of x we take, no matter how close to minus 4, but to the left of minus 4, when we plug it in to this function, absolute value of x plus 4 over x plus 4, we always get minus 1. Therefore, the left-handed limit is heading toward minus 1. Now, when we approach minus 4 from the right, the value of x, for example, will be minus 3.99. That's an appropriate value. It's to the right of minus 4, but close to minus 4. Let's plug that in. When we plug that in into the function, we get absolute value of minus 3.99 plus 4 divided by minus 3.99 plus 4. And both numerator and denominator are the same. In the numerator, we have 0.01. In the denominator, we also have 0.01. Absolute value of 0.01 is 0.01 divided by 0.01, so we have 1. Therefore, this right-handed limit is heading toward 1. The limit from the left is going to minus 1. The limit from the right is going to 1. That's an indication that the limit itself does not exist. So we can summarize it by saying limit as x approaches minus 4 of absolute value of x plus 4 over x plus 4 does not exist because the left-hand and the right-handed limit are different.